Hello everybody, welcome back. We are going to be talking about equivalent equations today. I know what you're thinking, those are two really big words, but guess what? We're going to learn exactly what they mean by breaking them down into more understandable words. So first of all, I want you to think about the word equivalent. Don't even worry about equations yet. Equivalent. Equivalent has a word in there that we are very familiar with. If you can just listen to it, equivalent. If you hear the word equal in that, you are correct. Because if I cover up the IV right there and the ENT on the end, the word equal is actually inside of the word equivalent. So the word equivalent is just a fancy way to say equal. And then equation is a fancy word for problem. So basically, today, we're making equal problems, okay? And we're very familiar with the equal sign. It looks like this, okay? And then for some problems today that are not equal, we're going to use the not equal sign, which is an equal sign with a line through it. So this means equal, and this means not equal, okay? And that's going to be important to remember when we are looking at our equations later on. First of all, we need to talk about the types of problems we're looking at today. We're looking at problems that have different operations on both sides. So it could be adding on one side and multiplying on the other, subtracting on one side, dividing on the other. Basically what we're doing is trying to see if those two different problems on either side of the equal sign are equal or not equal. And I'm going to show you exactly what that means. First of all, let me show you an equivalent equation. An equivalent equation means that it is an equal problem, okay? So we're looking at equal problems right here. First of all, I like to think of the picture of like a seesaw. Whenever I think of equal, we're like a scale, like an old-timey scale, where we have this thing in the middle called the fulcrum. And if you've ever seen a seesaw on the playground, you know that if you put one person on the other side and one person on the other side, if let's say we put a child on this side and an adult on this side, we all know that the child would go up in the air because the adult is obviously bigger than the child. But if we wanted to make it equal to where neither of them would go up or down, we would put a person over here, a child over here, and a child on this side about the same size, and then it would be equal, okay? Then you wouldn't really have that scale moving up and down. So today, that's kind of what we're doing with numbers. We're trying to make them equal, and the equal sign is kind of like the fulcrum in the middle of the seesaw, okay? We're trying to make this side balance to this side. So what we're looking at today is if I have numbers over here, a problem over here, and then a problem over here, but they both equal the same number, then this would be an equal statement. So let me show you how we check to see if this is true. First of all, we're going to start on this side of the equal sign. We're actually going to put the answer for 2 plus 5 kind of down here. And let's see what 2 plus 5 is. If I put 5 in my head and count up 2, 5, 6, 7. My answer here is going to be 7. So let's see if the other side equals 7. 14 divided by 2. I'm going to use one of our division strategies to solve this side. I see that there are 2 groups, so I'm going to draw 2 groups, and we're sharing 14 between the 2 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I see that each person got 1, 2, 3, 4, 5, 6, 7. So this side also equals 7. So these two problems, this is an equivalent problem. This is an equal problem because both sides equal the same thing. Now, what happens if both sides do not equal the same thing, then it is called a non-equivalent problem or a not equal problem. And that is when we would do our equal sign with the line through it. So let's look at a couple different examples. And we're going to decide today, is this an equivalent equation or a non-equivalent equation? Or is this equal or not equal? Okay, so before we put like the sign there, I'm just going to put a circle there because we're going to put either an equal sign or a not equal sign here. Okay, let's start out with 21 divided by 7. And then let's do 11 minus 7. Let's see what we get, okay? So, first we have to solve this side of the problem, 21 divided by 7, to see what we get. I know that I'm splitting 21 evenly between 7, so I'm going to draw 7 circles. You could draw 7 rows. This is just the easiest way for me to figure this out. And I'm going to put 1 in each group until I get to 21. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And if you divided correctly, your last mark should be in the last group or row. Okay, so I can look here and see that each person here got 3. So 21 divided by 7 is 3. Now, I'm going to come over here and do 11, take away 7. If you want to set up your subtraction problem like this, you can. Sometimes this is helpful. Sometimes you are going to get just the same problem. So there's more on the floor. I'm going to go next door, borrow some more, change that 1 to a 0, change this 1 to an 11. 11 minus 7 is 4. Okay, and I figured that out by putting 7 in my head and counting up to 4, put 7 in my head and counting up to 11 to find the difference. So 7, 8, 9, 10, 11, and I got 4 there. So that is where I got that answer from. So I've got 4 right here. So we have a not equal problem because this side is 3, this side is 4. So this problem here is going to get a not equal sign. Okay, and that is an equal sign with just a line through it. You don't have to have the circle around it. All right, let's try another problem. Let's do 3 times 6 equals 9 times 2. All right, let's see if this is going to stay the same or if we're going to have to make this into a not equal sign. Let's see if this is true or not. Because on your quizzes and tests, you're going to have questions, is this true or false? So let's see if this is true or false, T or F. All right, let's solve this side first. 3 times 6. For multiplication, we do 3 groups, and we put 6 in each group to get our answer. 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Same thing as 6 plus 6 plus 6. And if I counted up all of these, I would have 6 here, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this side would equal 18. Now let's see what 9 times 2 is. Now you can do a couple of different strategies here. You could either do 9 plus 9 as a double. You could do 9 groups of 2. You could skip count by 2 9 times. I'm going to do the double strategy because I know that I'm doing 9 2 times. So I'm just going to do 9 plus 9. And if I put 9 in my head and count up 9 more, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this also equals 18. Even though they're different multiplication problems, they both equal 18. So is this true or false? Is this equal or non-equal? This is equal, so this is true, okay? Let's do one more and see if this one is going to be true or false. I like the true or false ones because this is more what you're going to see on your SOL test, on your quizzes this week, on your assignments this week. You're going to have more of like a true or false thing. Is this true or is this not true? Let's do this problem. Let's do 10 times 2 is not equal to 38 minus 18. Let's see if that is true or false. All right, so this is a T or F question. So let's start by solving this side. 10 times 2, we know that this is just 10 doubled, or we could just say move the 0 to the end of 2, or we can skip count by 10s. I'm going to skip count by 10s 2 times. 10, 20. So I know this one super easy to figure out. 20. And then we're going to solve this side over here. Because these are both double digit, this would actually be a great one to stack on top of each other. Big number on top. All right, we start with subtraction. Is there more on the floor, more up top, or are the numbers the same? The numbers are the same, so 0 is the game. 8 minus 8 is 0. If you have $8 and you go spend $8, you now have $0. Next, we're going to move to the tens place and subtract 3, take away 1. More on top, no need to stop. 3, take away 1, leaves us with 2. So I can see that this would equal 20 as well. So this is an actually equal problem. The problem is, though, is that this has a non-equal sign. So is this true or false? Because this is saying 20 is not equal to 20. Is 20 not equal to 20? No, that's false, because 20 is equal to 20. So this is false because they used the wrong sign. And if you are not careful, this is a really easy thing to get tripped up on and to get confused, because we just get in this idea that everything is going to be equal. But on your SOL test, you're actually going to see this sign as a not equal sign. So you really have to stop, pause, and think about your answers. Say, okay, 20 and 20, so that is equal, but that's not an equal sign. So this whole equation is false. Now, if this had equaled 21, then it would have been true, because they would have been different numbers. So when you see this sign, you want different numbers. When you see the equal sign, you want same numbers. That's kind of an easy way to remember that. So when you see equal sign, you want same number, like 3 equals 3. And when you see this sign, you want different numbers, like 2 and 3. Both of these would be right, because that's what the symbols mean. This means that they're not. This means that they are equal. This means that they're not equal. Okay, so that's kind of the difference between the two. I hope this video helps explain equivalent equations and non-equivalent equations. We're going to be looking at some more examples as we go on this week. Good luck, and let me know if you need any help.